Okay, in the previous class, we have discussed how to find the Fourier series coefficient for a given signal xt. So we have seen that if xt is a signal which is periodic, we can decompose it in the form of a series which we call as Fourier series. And how we calculate this ak? It is given by 1 by t integration over one time period xt e raised to power minus j omega naught kt dt. Okay, so we will take one problem on this, a general problem. Let us suppose a signal is given to me xt. I take a square wave like this. This is a periodic signal, okay, extending from minus to plus infinity. And this is suppose t by 2, it is minus t by 2, and this point here is t1, it is minus t1. Okay, so t, capital T is the time period, minus t by 2 to plus t by 2, and within this time period some portion of the signal has a amplitude is equal to 1, in some portion this signal is 0. Okay, so if this is 0, so this will be t, this will be 2t, so t is the time period. Okay, similarly this point here is minus t, this point is minus 2t, and so on. So you have to find this general question, otherwise you can take any value of t, you can take any value of t1. Okay, I might take t as 4 and t1 as 1. Okay, so in that case this problem will become like this. If I take t is equal to 4, it means it goes from 2 to minus 2, and if t1 is 1, so it goes from minus 1 to plus 1. Okay, so it is a square wave. This is 0, this will become 2, so 4 is the time period, this will become 4, then 8, and so on. Okay, so it means it is a square wave in which half of the pulse width is 1, and for next half it is 0. So you can start from this point to this point. This is 1, then 0, then 1, then 0, and so on. Okay, but I'm taking this question and I have to find its Fourier series. Okay, so I have to find its coefficients first, ak. So first we find a0, which is the constant or the DC component. If I find ak, it is simply 1 by t integration from 0 to t, or integration from over one time period xt. If k is 0, a raised to power minus j omega naught kt is 1, it is dt. So a naught, it simply gives you the average value of the signal. Okay, which is called the DC component. Now in this integration 1 by t, t is the time period. When you integrate this function, you can integrate it for any time period. You can integrate from this point to this point also. You can integrate from this point to this point also, or you can integrate between this point to this point also. It is up to you. Okay, because since the signal is periodic, the integration for any one time period will be constant, it will be same. So we integrate for this case from suppose minus t by 2 to plus t by 2. Okay, xt dt, and you will see that between minus t by 2 to t by 2, the function is non-zero only between minus t1 to t1. It is 1, otherwise it is 0. So this integration will from minus t1 to plus t1, and xt is 1 between this time. So it becomes simply 2t1 by t. a naught, the constant term. And then you have to find ak for k not equal to 0. So again is this equation, it becomes 1 by t integration over one time period. Again I take from minus t by 2 to t by 2 xt e raised to power minus j omega naught kt dt. So it becomes 1 by t integration from minus t1 to t1 again, because minus t by 2 to minus t1 it is 0. t1 to plus t by 2 it is again 0. It is only non-zero between minus t1 to plus t1, and that is 1. So 1 into e raised to power minus j omega naught kt dt. Okay, so if you solve this integral, it becomes 1 by 2. Integration of this will be e raised to power minus j omega naught kt minus t1 to t1, and from this factor you'll also get minus j omega naught k in the division. Okay, so if you apply the upper and the lower limits here, you will get minus 1 upon j omega naught kt. Upper limit is plus t1, it will become minus e raised to power j omega naught k t1 minus e raised to power minus j omega naught k t1. In the lower limit will become plus, because it is already minus t1 here, so minus into minus become plus. Okay, so or I can write this equation as, so my ak will be, I can take minus common from this, it will become minus and this minus will become plus. You will get 1 upon j omega naught kt into e raised to power j omega naught kt1 minus e raised to power minus j omega naught k t1. Okay, so if you multiply this with 2j and divide with 2j, this will become a sine function, and this j and this j will get cancelled. Okay, so what you will get, you will get ak as 2 upon omega naught kt into sine of omega naught k t1, or in place of this omega naught or t, you can write t as 2 pi by omega naught. So this omega naught will get cancelled, this 2 and this 2 will get cancelled. What you will finally get, sine of omega naught k t1 upon k and pi. This is my ak. Okay, so this is the Fourier series coefficient for this. We have already computed a naught, which was 2 t1 upon t, and ak for k is equal to plus 1 1 2 3 plus minus 1 plus minus 2 3. This is ak. So if you plot it, what you will get, I have taken a signal like this. Okay, this was t by 2 to minus t by 2, this was t1, this point is minus t1, this one xt. And for this signal, when I computed the Fourier series, I got constant term as 2t1 by t, and ak I have obtained it as sine of omega naught kt1 upon k pi when k is not equal to 0. Now we take some specific example here. Let us suppose I take a case where your t is 4 times t1. Okay, t is 4 times t1. It means if I take t1 is equal to 2, your t will be equal to 8. If I take t1 is equal to 1, t will be 4. Anything like this. Okay, isn't it? It means I can have it like this. Suppose if my t1 is equal to 1, your t will be equal to 4. So you will get a pulse like this, a signal like this. T1 is equal to 1. So it means this is 1, this is minus 1, and this is t by 2. So t is 4, it will become 2 to minus 2. This is 0, this will become t, that is 4. This will become 8. This point will become minus 4 and so on. A signal will be like this. Okay. Or if you take t is equal to 1 by 2, your t will be equal to 2. You can generate any signal from this. This is general case. So if t is equal to 4 times t1, what will be my Fourier series coefficients from this equation and this equation? First you will get a naught. For this case, what will be a naught? 2t1 by t. 2t1 by t is 4 times t1. It will be 1 by 2. Constant term, a naught. And what about ak? It will be sine of omega naught. You can write it as 2 pi by t into k to t1. T1 can be written as t by 4 for this case upon k times pi. Okay, so it will become this t and t will get cancelled. 2 and 2 4. You will get sine of k pi by 2 upon k pi for k not equal to 0. If you plot this function ak, how it will look like? Sorry, this is k here and this is ak. So for k is equal to 0, you have a0 which was 1 by 2 constant term. Then k is equal to 0, this is suppose k is equal to 1, then 2, 3, 4, 5, 6, 7 and so on. Similarly a minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and so on. Okay, so a naught is 1 by 2. What will be a1 from this equation? When you put k is equal to 1 in this, you get sine of pi by 2 upon, it will become sine of k is equal to 1 pi by 2 upon pi. K is 1, so it will become sine pi by 2 is 1, it is 1 by pi. So at k is equal to 1, the Fourier series coefficient is 1 by pi. Okay, then for k is equal to 2, you'll get a2. So when k is equal to 2 in this equation, you'll get sine of pi. So sine of pi is 0, so a2 is 0. Similarly a3, a2 is 0. Then a3 is sine of 3 pi by 2. So sine of 3 pi by 2 is minus 1. So minus 1 by k is now 3, 3 pi. Then a4 is again 0 because it becomes sine 2 pi, sine 2 pi 0. Then a5, so a5 will become again 1 by 5 pi. Then a6 and so on. Okay, so if you plot its Fourier series coefficients, for this case t is equal to 4 times t1, you may have a signal like this or any other signal. So at 1 it is 1 by pi, then 0, then at 3 it is minus 1 by 3 pi, then at 4 it is 0, at 5 it is 1 by 5 pi, then at 6 it is 0, at 7 it is minus 1 by 7 pi, then 0 and so on. So you have one positive coefficient, then 0, then one negative coefficient, and the magnitude of this will go on decreasing basically. It will be oscillating like this. And similarly on the negative side. Okay, because it is sine function, so sine of minus theta is minus sine theta, and in the denominator you also case when k becomes negative, so minus k and minus they will cancel each other, so whatever is on the positive side the same spectrum will get on the negative side. Okay, so if you find the Fourier series for this signal for t is equal to 4 times t1, you have a Fourier series coefficients like this. So what it means, you have one signal which is constant, that is 1 by 2. Plot this signal, it will be like this, 1 by 2. Okay, we have another frequency, first fundamental frequency when k is equal to 1, that is 2 pi by t, and the magnitude of this will be 1 by pi. And the second harmonic is 0. It means this signal, it does not contain any frequency 2 omega naught. Then 3 omega naught is there, which has a magnitude of minus 1 by 3 pi. Then 4 omega naught is again 0. It means this signal, it contains only the odd harmonics. All the even harmonics, they are basically zeros. Okay, so 2 omega naught frequency is not present, 4 omega naught is not present, 6 omega naught is not present. So you have frequency omega naught, then 3 omega naught, then 5 omega naught, 7 omega naught, and the magnitude of these frequencies will go on decreasing as increase k. It means as at the higher harmonics, the frequencies they have lower and the lower magnitudes. Okay, similarly, if you take a case where suppose I take t is equal to 8 times t1. Okay, so what will be ak in that case? From this equation, this will be t1 by 8, so I will get it as sine of k pi by 4 upon k pi. So if you plot it from this at k is equal to 0, you will get 2t by t, or t is 8 times t1, it will become 1 by 4. And at k is equal to 0, k is equal to 1, you will get sine of pi by 4 upon pi. Then at k is equal to 2, you will get sine of pi by 2 upon 2 pi, that is 1 by pi, and so on. And when k becomes 4, here you will get pi by 4 pi by 4, that is sine of pi, will become 0. It means at 0 you will get positive value, then at 1 you will get positive value, then at 2, then at 3, at 4 it becomes 0. Then similarly it will become 0 at when k becomes 8, because it becomes sine of 8 pi by 4, that is sine of 2 pi, again 0. It means between these two simples, 4, you have 5, 6, 7, then at 8, 0. Then 9 is non-zero, 10, 11, 12 is again 0, and so on. So 3 non-zero samples, after that we'll get a 0 samples. So 3 negative samples, 0, then 3 positive samples, then 0, and the magnitude of these of course will go on decreasing as k increases. Okay, it means when t is equal to 8 times t1, in that case you have the DC component, you have first fundamental frequency omega naught, then you have 2 omega naught also there, 3 omega naught also there. So 4 omega naught is not present. Then 5, 6, 7, 8 omega naught is present, and so on. So multiples of 4 omega naught, they are basically not present in the signal. Okay. Similarly, if t is 16 times t1, you will get pi by 8 here in this equation. It means when k becomes 8, there you get the first 0 point. Okay, and that's 16. then at 8 into 3, 24, and so on, right? So this is how you find the Fourier series for any signal. Okay, the signal will be given to you. So from that, you have to first find what is my time period. From time period, then you have to calculate what is the fundamental frequency, and then you have to find AK and A0. So you can put back into the series, you will get its Fourier series coefficients. Okay. So I give you a small problem. Suppose a signal is given to you like this, and I take a signal like this. This point, okay, let us this is a signal xt which is given to you, which is a periodic signal, of course. Okay, and this time piece was 0, this is 4, and this is 2. Okay, this is -2, this is -4, and so on. So you have to find its Fourier series. Find the exponential Fourier series for this signal for xt. Okay, now so in this question you can simply calculate what is my time period. So time period for this you can compute from this signal, it is this much. If you look at the time period, it is this one. Okay, this is one time period, and then it repeats with this time, so on. Similarly from the left side. Okay, so time period for this is 4. It means omega naught, it is simply 2 pi by t, it is 2 pi by 4, it is pi by 2. So fundamental frequency of the signal is pi by 2. It means when you decompose the signal in terms of the Fourier series, so you have to find A0 first, the DC component, and then you have to find AK for K not equal to 0, A1, A minus 1, A2, A3, and so on. So A1 will give you the fundamental frequency, that is omega naught, which is pi by 2. It means this signal will contain one frequency pi by 2. The second frequency will be 2 into pi by 2, that is pi, then 3 pi by 2, then 2 pi, and so on. Okay, so you have to find this series.